All right, if you have your book with you, I'm going to go over Chapter 4 right now. My hope is that we can get done with this chapter and ideally the review also by around 10 o'clock. All right, so let's see. Again, I'm on page 133, and in this chapter it says understand logic, planning tools, and decision making. Again, goes back to what I mentioned to you before about taking a problem and breaking it down into sub-problems and solving those. Making decisions using the if, just an if, and I showed you that with our exit routine, where if that message box, if you chose yes, you exited, otherwise you did nothing, and the if else. We did that with that keep going variable, where if it was true, we did one thing, if it was false, we did another thing. You can also make complex expressions. All right? And when you use these compound expressions, you use and, you use or, and you use not. All right? So imagine, I'm just going to just say it to you right now, that I decided that I'm going to throw a party. And if you want to come to the party, two things must be true. You must be over 21 because we're serving alcohol, and you must be a student in the Rankin-Wentzville AWD program. And means both of those have to be true. So if either you're not a student in the AWD program, or if you're not 21 or over, or neither one, you can't come to the party. Does that make sense? So with an and, all the conditions must be true. So now it's 2 days before the party, and hardly anybody's coming. And I've got a lot of booze, etc., so I change it to an or. Now only one of those have to be true. Either you have to be greater than 21, greater than or equal to 21, or you must be a student in the Rankin AWD. All right, so now people who are in the Rankin AWD program who are less than 21, they can now come. Now people who are not in the Rankin AWD program can come if they're greater than or equal to 21. That's an or. So an and is being very restrictive, an or is being less restrictive. You also have not. So one way of saying single is not married. All right? One way of saying negative is not positive. All right? And when you work on that in here, we saw this in the JavaScript class last semester, that when you have and, it's two ampersands. When you have or, it's two pipe signs. That pipe sign is the thing right up above your enter key. And when you have not, it's an exclamation point. When you've got a complex expression, you can have all of these in here. You can have nots, you can have ands, you can have ors. All right? So, if I've got a bunch of them, what do I do first? You do the nots first, then you do the ands, then you do the ors. Why? Because they go from the most restrictive to the least restrictive. All right, so keep that in mind because you're going to see that again. Then we learn about another way to write an if, and that's using a switch statement. All right. Then we learn about a special kind of statement called the conditional operator, which depending on who you are and what you think of it, either, wow, I love this, or, yeah, that's fine, I'll never use it. Okay. The not operator I just mentioned, avoiding common errors, making decisions, and appreciate decision-making issues in GUI programs. Really the heart of being able to write regular programs like we've written so far. All right, you've already learned a few things, whether you realize it or not. Number one is you've learned sequence. So if you have 10 lines to do and you do number 1, then number 2, then number 3, all the way through line 10, and you don't deviate, that's doing stuff in a sequential order. All right. In this chapter, we're getting into what are called selection statements, where you can change the order based on something. And in the next chapter that we'll go through tomorrow, we'll go through looping, when you want to repeat statements over and over and over again. All right. So, when you lay out a problem, some people like to go and write pseudocode. What's pseudocode? It's kind of fractured English. It's sort of half English and half programming language. All right, you'll see an example in a minute. Other people like to use a flowchart, which is pictorial. All right, I mentioned sequence to you already. Here's an example. If you look on the screen, that's an example of what's called a flowchart. All right. Back in the day, that's how I had to solve every program I had when I was in your shoes, sitting there as a student. All right. You had to flowchart every program you were going to do, and until the instructor said your flowchart was okay, she or he would not give you the input data that you needed to run the program. All right. So that's an example of that. Now, on the other hand, this is more like pseudocode. You go, well, that's English. Yes, it is. But the idea is if you've got pseudocode or if you've got flowchart, you can write a program in any language you know. So, this is a decision structure. It's what I mentioned to you before. Again, you ask, in this example right here, you're on Algonquin Road going west. All right, you turn left onto Roselle. And so then what do? What the author is saying here is you go and you look, go, wow, that expressway looks really busy. So if it is backed up, you'll go this way. No, it doesn't look too busy, so you go that way. One advantage that I get when I come in here, you know, when I leave my house, it's usually about 4:45, and usually I don't have a problem. Today I saw 2 trucks on 64. That was a lot of traffic. All right. The way that you write this stuff is you say if, and you may or may not have noticed that before, but what goes in the parentheses is what's referred to as a Boolean condition. You already know what Boolean is. It can be true or false. So if you put an if, and if it's true, you do the stuff with the if. If it's false and you have an else, you do the stuff by the else. If it's false and there's no else, you do nothing. So, making decisions with the if. Again, what they call right there tested expression, that's a Boolean condition. And the author even says that in here. So there's an example. If you look over, I don't know why this thing is running so slow, but it is. There we go. If you look up on the right-hand upper corner of the screen, we're going to assume here, so in other words, let's say number is equal to 8. All right? Is number less than or equal to 5? No, it's not. All right? So you skip that line and you write B. Now, number is negative 8. Is that less than 5? Yes. So you do this and you do this. So you'll end up writing A, then you'll write B. All right? Kind of a silly example. That's the one that we're given in the book. And the author tries to give you what she considers to be some do's and don'ts type of thing, which is true. All right. Now look at how this has changed once this catches back up. The good news is, talking to Mr. Corrigan, according to him, I'm getting a new computer. This one is like 6 years old. That's the good news. The bad news is it won't be until our new budget cycle starts on July 1st. So I've got to deal with this one the rest of the semester. All right. So if the number is less than 5, I want to do 2 things. So notice, if you want to do more than one statement, you must use curly braces. I recommend, even if you have one statement, always put it in curly braces. All right. Some people believe that, some people don't. But this will check the number. If the number happens to be 5, you don't do anything. So if it's 5 or above up here, you do nothing. If it's 4 or below, you'll write both of these. You'll write C, then you'll write D. You can also have an if within an if. All right, I'd like to show you that. I don't know if this right now is going to make a lot of sense or it's not going to make a lot of sense. All right, well, let's say we've got two variables in here. So I say int x equals 7, int y equal 12. This is all off the top of my head. So I can say, for example, if x is greater than 3 and y is less than or equal to 50. All right. Tell me if that's true or false, if you would. Is this true or is it false? Somebody. Is x greater than 3? That's true. Is y less than or equal to 50? Yeah. So the whole thing is true. All right. If I didn't want to write it like this, I could write it like this. I could say if x is greater than or equal to 3, then I check if y is less than or equal to 50. All right. So if I had some code here and some code here, that's what's called a nested if. With a nested if, you write an if inside of an if. All right, you can nest anything. You can put almost virtually any kind of statement within any other kind of statement. She's got a lot of pages in here that just have picture after picture of flowchart. All right, not sure why, but she does. All right, please look on page 143 or look up on the screen here, if you would. I want to make sure that you understand the code that's here. So we've got two constants, one called high that's 10, one called low that's 5. All right, and then we're told to write an integer, and we convert it. So let's say that the integer that we put in is 7. All right, so we put in 7, and 7 becomes number. If number 7 is greater than low, so if 7 is greater than 5, it is, then we come in here and we do this. Now, is the number 7 less than 10? It is, so we write all this. You have to be able to follow that kind of logic. All right? What they mention here on page 144 is one of the nice things about Visual Studio is Visual Studio automatically, all right, indents for you. If you don't like the fact that it automatically indents for you, you can turn that off. Most people like it. All right. So when you've got a single alternative, that's just an if. If you've got a dual alternative, that's an if-else. Again, if you would please, look up, once it comes, there we go, on the screen, if project is under budget, you get a bonus of $200. Otherwise, you get no bonus. Does that make sense? So you will check the value of is project under budget, which will be true or false. If it's true, you get a bonus. If it's false, you get no bonus. It's one or the other. Again, the author keeps drawing these as flowcharts. Some people really like to learn that way. Some people find using things like flowcharts, all right, to be a little bit confusing. Now, here's kind of an important fact. If you look on the screen here, and you look at this example that's right here in blue. All right, erase my foot up here. Okay, people sometimes end up thinking, okay, this else right here, that else must go with that if, because they're lined up with one another. Not necessarily. All right. And the rule is, and they mention this down here, so let me get rid of this. The author says, in this example, the following bonuses are assigned. If the sales amount is greater than 1,000 and it's less than 2,000, so if it's in between those two, you get a $100 bonus because they're both true. If the first one is true but the second one is false, you get a bonus of 500. So in this case, they do line up. But don't think just because two things line up to one another that means, oh yeah, I got to do this or I got to do this. It may be that way, it may not be. All right. Then there's a you do it on pages 148, 149, and 150. I can't say this to you too many times. If we go through this and you're like, man, you're just blazing through this, I don't know how much I'm understanding. Go back and go through the you do it's. They're usually 2 or 3 pages long. The author gives you a program, and first she says, we're going to write a program that's going to do this. Then she shows you all the code, all right, and explains it to you as she's putting it in. And then when she's done, she goes and runs it and says, here's basically the type of result you should get. All right? The compound expressions on page, which starts on page 150, that's that and or that I mentioned to you before. Okay? Do people understand this? If just, you don't have to look, but just please listen for a second. Back when I went for my master's degree, I have virtually no knowledge at all of computer hardware. None. So I decided, you know what? They let me take a couple classes that I wanted to take that were computer classes, but they could be on anything. So stupid me, I took 2 hardware classes. All right? And in the first one, I don't know if you've ever seen these because they were more popular when I was a kid, but they gave us this little box that was a Heath kit. And they had a whole bunch of stuff in there. I had to program this so that when you put a tester on something, if the if was true, that turned red. If it was false, it turned blue or whatever. That was what I had to do in the class. And that's how the computer handles it. All right? So the computer says basically your Boolean check, if that Boolean check is a 1, it means it's true. Do something. If it's a 0, it means it's false. Don't do that thing. And that's what the author is talking about right here. And in fact, to show it to you, they show what are called truth tables. With an and, everything must be true, or the whole thing is false. With an or, anything must be true. The only way it's false is if everything is false. They're not quite opposites of one another, but they almost are. Again, you can use this stuff together in statements. So you can combine ands and ors. If you combine ands and ors, you do the ands first, then you do the ors. If you want to do the ors first, you use parentheses. There's another you do it here on page 157. Again, it's 2 pages long, where again the author goes through and demos using ors and ands together to hopefully make sure that you understand what's going on. All right? Now, if you don't, please, for a second, look up on the screen here. I'm going to write that this is kind of fractured code. So it's not real code. Okay? But I'm going to come through here and I'm going to say this. Int, let's see. Yeah, okay. Size, and I'm going to set that equal to 0. Int, and I'm going to call this size str, and I'm going to set it equal to that. All right, and then I'm going to say, write, what size are you? and I'm going to say size string equals read line. All right. Look on the screen if you would, please, everybody. Just indulge me for nothing else. Does what's up there make sense to you? In other words, you're running this on the computer. So here is the computer right here. And it's going to come up and it's going to say, what size are you? Okay? And I come through here and I say XL, for example. Then XL is going to be assigned to that. Does that make sense? All right. So let me erase this and keep going. So if I come through here and I say this, so I'm going to now write some ifs. So if I say here if size string equals S, let's just say for small we put it in S. Right line, you are a small. All right. Else, if the size is an M, you are a medium. Else, if the size is an L, you are a large. And let's just suppose that's the only three sizes we have. Else, so we come in here and we say unknown size. Make this smaller so we can show all of it on the screen. My question to you is, if you look at that, does that code make sense? Yes or no? Does that code make sense? That's going to prompt you. Now you might put in here, what size are you? I might put in, for example, S, M, or L to try to make it easier for the user to understand. That's one of the ones I'm looking for. So if you put an S, it says you're small. If you put it in M, it says you're medium. If you put it in L, it says you're large. If you put in anything else, it says unknown. Does that make sense? All right. Well, another way I could write this, just so you see it, all right, another way I could write this would be like this. I'm going to grab this same stuff that we have right here. Everybody saw this. You told me, at least you saw it. Hopefully you understood it. But I'm going to rewrite this, and now I'm going to come in here and I'm going to say this. Switch on size string. Case S right line, you are a small. Break. So if you would please look up on the screen, I have rewritten that series of if statements by using what's called a switch. I know we looked at some of this stuff last semester, so those of you who are in the Java class have probably already seen this or something that looks similar to it. All right? So this right here, everything that we have in here is the equivalent of what we did up here. All right? So why should you use this one instead? You don't have to. anything that you do with a switch statement, you can always do with an if. The reverse is not true. Sometimes there's things that you put in for a switch, for an if, that make no sense in a true. All right? Now, look at this, because there are certain things that you have to understand. Switch is a key word. What you switch on, you put in parentheses. That can be a string, or it can be a whole number. All right? This is like says, if it's an S, if it's an M, if it's an L, if it's none of those. So it's another way of being able to write an if statement. All right? I would not give you a test where I would say, hey, you've got to do this, and you've got to do this one as an if, and you've got to do this one as a switch. It's very much an individual's point of view as far as what they'd like. All right? But I want to just show you one quick thing about this. All right? I'm going to go back to my code that I had here. I'm going to grab every bit of it, and I'm going to put it back in again, but I'm going to change this. So this is going to say int grade equals 0, int string L grade equals the empty string. All right, so I'm going to say here, enter a grade. And we'll let the person know 0 through 100. Those are our valid values for the grade. All right? So grade equals, we can't do a read line because it's an int, so we need a convert dot to int 32 of read line. All right? Now we come in here and we say if the grade is greater than or equal to 90. All right, then we write, we won't even do a write line. We'll just say the letter grade is an A. Else, if it's greater than or equal to 80, the letter grade will be a B. Else, if it's greater than or equal to 70, the letter grade will be a C. All right. Else, if it's greater than or equal to 60, it's a D. I should have semicolons at the end of all these. And we'll just say else your letter grade is an F. Please look at that and make sure that the logic that's in there makes sense to you. So let's suppose the person got an 83. In fact, let's look at all of them. 93, 83, 73, 63, 53. All right, they got a 93. Is 93 greater than or equal to 90? Yes. So we're going to do that one. Then we skip all those. Then we've got an 83. Is that greater than or equal to 90? No. Is it greater than or equal to 80? Yes. So we do that one, and we skip all those. Then we do 73. Is that greater than or equal to 90? No. Is it greater than or equal to 80? No. Is it greater than or equal to 70? Yes. So that person gets a C. We go down again, and that person gets a D. Finally, we get down, and that person gets an F. Does that logic make sense to you? All right. People think, well, I have to write down if it's greater than or equal to 80 and it's less than or equal to 89. You can put that in there. But this is going to handle everything from 90 to 100. This will handle 80 to 89, 70 to 79, 60 to 69, and 0 to 59. All right? That's the good news. The bad news is if I decide I want to come in there and I want to write this same thing that you see right here, I'm going to get rid of all that. If I want to go back and write this as a switch, then I've got to do it like this, and you'll see how bad this is. You probably would never do this. So I can say switch on. Great. Now, I have to actually write all these. So I have to say case 90, case 91, case 92, case 93, '94, '95, '96, '97, '98, '99, 100. Then I can come in here and say grade equal A. Do you understand why you wouldn't want to do this? You would end up writing out like 100 or 102 of those. I wouldn't want to do that. That's just silly. All right. But they explain in the book, the author does a nice job here on 159 of saying, here it is as an if. Let's rewrite it as a switch. In some cases, the code becomes much, much easier to read. All right. It starts with the keyword switch. All right. The thing that you switch on is the case label. It's a switch expression, and each one of the cases is a case label. That's what they explain on page 160. All right. So here's an example, and the author goes through this in a lot of depth and breadth of coverage. If you look up on page 163, there's this example. You may or you may not remember this, but again, if you look up on the screen here, junk. That's called an enum. So instead of doing a switch on one, you can do a switch and say accounting. Switch in CIS, English, math, etc. But the point is, this could be done very easily using a series of ifs as well. Sometimes switch means that you end up with a little less code. That's all. All right, give me 5 more minutes, 10 at the max, and we'll be done with this chapter. All right, the next thing that's on page 164 is the conditional operator. All right, show you this fairly quickly. All right, I'm going to come in here and say int x equals 23, int y equals 17, int max equals 0. If x is greater than y, let's say greater than or equal to y, max equals x. Else max equal y. Somebody look at the screen, please, and tell me, what is max equal to when you get done? It's not a trick. Try again. Is x greater than y? Is 23 greater than 17? So we set max equal to x. All right. If we reverse these, then you'd be correct. So if that was 17 and that was 23, now x is not greater than or equal to y, so max would be y. All right. But what I want to show you is this. If you look on the screen, that's 1, 2, Try it again. That's 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Everybody agree with that? It's 8 lines of code. I can rewrite that. Whoops. I can rewrite that as 1 line of code. So I can say max equals x greater than or equal to y, question mark, x, colon, y. That's called the conditional or ternary operator. This right here is saying if x greater than or equal to y. That's what that's saying. This says if that's true, then you say max equal x. This, if it's the colon, says else max equal y. So you can rewrite that multiple lines of code as a single line of code. Sometimes there's places where that can be used, and it really results, as you can see, in a lot less code. If that confuses you, don't use it. All right. They explain it. They said that it's a ternary operator because it requires 3 arguments. The test, what to do if it's true, what to do if it's false. The not operator we already talked about. Not is an exclamation point, and it's an inverter, so it changes true to false. It changes false to true. All right. About 5 more pages left in here. Common errors when making decisions. Look on the screen, because you'll all make these. I make them. Everybody makes them. There's a bulletized list on the top of page 167. Whenever you're testing for equality, use double equals, not single equals. If I say if x is greater than or equal to 3, do not, after the parentheses, do not put a semicolon there. If I want to have several blocks after the if or after the else, I must use curly braces. It's easy to screw up an and or an or. An and needs something on the left and something on the right. So does an or. If you choose not to put something in there, you're going to get an error message. All right. Range checks. This gets confusing. What if I want to check? I'm asking you this question. What if I want to check to see if a person's height is between 60 inches and 74 inches? Then I'd say something like if height greater than or equal to 60 and height less than or equal to 74. Does that make sense? All right. So when you're checking for a range like that, if something is included in a range, you use an and. If you're checking to see if something is not in a range, you typically use an or. And that's what they're saying right there. All right. And she gives a bunch of examples. So again, look at this, because I've seen people write code like this. This is a logic error. You look up on the screen. It's going to flip back in just a second. Come on. Come on. Look at that example about the pay rate. It's right near the top. It says, if pay rate is less than 5.65 and pay rate is greater than 60. Does it make sense that could never be true? How can something be less than 5 point something and be greater than 60? Doesn't happen. That you should be using an or in. Then it makes sense. All right? It's very simple to make a mistake and use an and when you mean to use an or to use an or when you mean to use an and. All right? Finally, the last thing that's mentioned in here decision-making issues in GUI programs. All right. And what do we have? Show the age. Show the movie rating. Do they get a discount? All right. The bottom line is you're still going to write the same kind of if that you'd write in a console application. Okay. That's pretty much it. So let's turn to the end of the chapter and go over the chapter review. Now, again, I got asked this at the beginning of class, so I'm mentioning it again. This is chapter 4 of 14. So right now, tomorrow, by the end of the day tomorrow, you should have handed in these chapter reviews for chapter 1, chapter 2, these review questions, chapter 3, and chapter 4. All right? The other ones were actually